So, hello everybody. It's a next webinar about object-oriented programming, and I will try to, within the next 45 minutes, I'll try to explain you what I think about private static literals, basically magic numbers, constants, all this stuff. And actually not only private, but also public as well. I named this webinar private static literals, but I think we may also discuss public thing as well. So let me give you a practical example of what I'm talking about. Let's say I was thinking what kind of an example to give you, because there are so much code around us where people use this stuff, and I decided to not to take a real example, but to make it up, and for the sake of discussion. So let's say we have something very simple, for example, address, which is a web address, and then we have let's say a private final, it's Java, by the way, private final host name, and then private final anyway, something simple like this. And then we have a function, public string, let's call it URL. So we want to build the URL, and we do like this: return, let's say HTTP, this plus host plus I think so. Is this gonna work in Java? I think so. Anyway, the next line is gonna be let's call it HTTP, and let's call it HTTPS. So for the HTTP we do this, for the HTTP we do this, and let's put something very simple here. Let's say we use I don't know, home page. So let's say we have a very dumb piece of Java code which works, as you can imagine, which returns what we want to return, but we have stuff which anyone who writes about clean code, about good code, about best coding practices, everybody will tell you that this is called magic number. Magic number, and this one is called a string literal. So this is string literal, and 80 is a magic number, which is a horrible practice. That's what people say. That's what those, everybody say who write about any programming, not only object-oriented, any type of programming. And the solution they propose, many people propose, is to change this code and introduce a private static final string colon. This is the literal, and this is for the port 80. And then you change this one for the port, and then you change this one for the port as well, and then you change this one for the colon, and then you change this one for the colon, and then for the colon, and boom, the problem is solved. It seems that now everything is great, the problem is solved, and really like super talented programmers may do it even like this. They say slashes, boom, and then you make it like this, slashes, and then you make it like this, slashes. That's awesome, right? The people may say like, look, we don't have magic numbers anymore. We have constants everywhere, which is great, right? Because why it's great? The point is that why these magic numbers are not good, because I think there are a number of problems, but the biggest problem is that they duplicated, that they happen to appear in many places, like here, port here and port here. They are in the same place, and the number 80 was staying here before, and number 80 was here as well, which means that if something happens, if we need to change something, for example, we decide that the HTTP is not going to be on port 80 but on port 8080, then we're gonna change it in two places. So we'll have to go in two places and change it here and change it there. And that's not good. That means code duplication. It means that we will have the code less maintainable because we need to remember this information. And this information is nowhere. Like if the number is 80 here and the number is 80 here, then it's true that the information is nowhere. Like, for example, tomorrow I will put some code in here, and then I look at this code like this, and then something else is there. So I don't see that line. I don't see that line anymore. So all I see is this line, and then the pull the change request, the feature request comes in, and the customer wants 8080. So what I do, I just change it here, and I forget about the second line. And the more lines like this over the code base, the bigger the problem, the bigger the trouble. So I need to remember it somehow. Of course, I can put some documentation here and say, I don't know, maybe like this, like, I don't know, don't forget to change it 55 lines below. But that's kind of silly, right? That kind of comment, because what if I go down and change there? Anyway, you understand the problem. It's silly. This is not a good approach. So the problem is obvious, that we don't want code duplication. We don't want to stay that one number or one magic number, magic string, to stay in multiple places, because they get disconnected eventually. They will be in multiple places, and we will not know that they have to be changed at the same time. So if we move the port number here, then of course, if I want to change it to 8080, then I just change it there. It seems like a good intent. It seems like a good idea in general to get rid of code duplication. So the problem is obvious. The code duplication is horrible. I'm not going to argue with this. I totally agree that that's a problem, that we have the same numbers here and there. I just don't like the solution. I don't like how it's being solved. I don't like this code at all. It's just, in my opinion, it's just wrong. It's totally wrong code. And I can explain why, and I can suggest you what is the better code a few minutes later. So that's the first problem. They are disconnected. So this number 80 is not connected to this number 80 anyhow. The second problem is that number 80 here or number 80 here doesn't have enough semantic information, meaning that we don't know exactly what 80 means here. Of course, when we write this code, we understand that we just build the URL. But today it's obvious, tomorrow it's not going to be obvious. So there is no semantic around this number 80. It's just the number 80, which is a problem for the maintainability, because a few years later you will look at this number 80. Of course, for the 80 number, you're not gonna think twice, because you know it's a HTTP port. But if the number will be something more complex, then let's say we build the port number here like this, then you're gonna look at this and say where it's coming from, why it's 6733. So what was the idea behind this number? If you move it here, of course, it's easier to document your magic number. You can say like this port is the one we are getting from the configuration, configuration of the configuration in the file, settings XML, which is provided by the blah, blah, blah. So it's a real proper, you can even make it like this. You can make it like a proper piece of Java block. In this case, it's a real proper documentation. I can even say something like really fancy here. I can say, I'm the author of this, and this constant is here since version number 55, something like this. So I can provide a lot of meta information for the magic number. And then it will be easier for the future to document it and say, I'm not sure, or something, I'm not sure it works because this and that, blah, blah, blah. So this long piece of documentation finds its place. It's the proper location for the documentation. We cannot put the same block of text over here, right? And especially if we have it in two places, we're not going to document it here and here. We don't want to duplicate the text. So that's why we move the constant here, and we document it where it's supposed to be documented. But I still don't like it. I still don't like it, and I explain you why. But you understand the problem. That was my point. That was my intent right now, to demonstrate you that magic numbers are actually a bad idea, and magic strings or magic numbers, something which stays there without the semantic and without connection to each other, it's a terrible problem for maintainability. Now the solution is as bad as as before. Why is that? I think that the first, number one, maybe the only problem is that we disconnect, in this case, in this text, in this code, as you can see right now in front of you, we disconnect the code that needs the number from the number with the information about the number. They are disconnected. So we use this port here and we document it somewhere here, which means that thanks to this disconnection, because of this disconnection, we may eventually do something like this in the future, introduce a new method and say, for example, I don't know, let's put it this way, let's call it int something like that. So we introduce a new method. When I introduce the new method, I read the class, I go through the class, I find a static literal, I see that the port is here, it's 80, and the number I'm supposed to return is 80. So initially I write it like this, and then I see, okay, 80 is here, 80 is there, so how about I change it here? But when I'm doing this, I don't look at these methods. I don't see them because I kind of don't need them. I jump into this class like this. And I write, okay, 80, and then boom, I see the constant here, port, seems to be like good for me. I have 80, that's the port. So I change it here. I introduce a new dependency of something very new, which is probably not related to the code below. And I connect this stuff to this port without asking the permission of people who were here. So I'm not consulting with them. I just connect to this constant because it's available. It's like an abandoned data. They're just hanging around, waiting for somebody to use them. And all we know about this data, in most cases, that it's like this. In most cases, it will be like this. Just port, just number 80, use me. Do whatever you want, I'm available. Just take me and use me. If you need number 80, you can use me. For example, you need number 100? Oh, great. How about this? Yeah, this works because I need 100 and I have 80. So how about I need 80, 80. So how about I multiply it and then I use like this? Cool, right? Sorry. Yeah, that's going to return me 80, 80. But that's a total mess because this 80 means something different. And if tomorrow the people who are writing this code will come back and say, you know what, it's not 80 anymore, it's actually 8080. This code will have no sense whatsoever. It's going to be garbage from now on. So we introduce dependencies which have no sense, which have no meaning, which are meaningless, which are artificial. They're not real. The real meaning was here. Okay, it was port 80. That was port 80. That was okay. These two places actually meant to have this number in here, number 80. But then a new guy jumped in, picked up the constant, picked up the magic number because it seemed like a relevant one, and it just frivolously, let's put it this way, put this number in use. And this is what this private static literals are begging for. Use us when you need me, use me. It shouldn't be like this. This is how we introduce dependencies, which eventually will only harm the code, only introduce more mess. So this is even better than this private static literals. And I'm not even saying how terrible it would be if we make it public. If we make it public, not only this class will be able to do this mess, but any class in our source code will be able to do that. Imagine how messy we can get. Now only the internal methods from here can use this constant, which is in most cases okay. It's going to be more or less safe because there are not so many methods, just a few, and we can still look around and see, you know what, it doesn't look like a normal code. Something is wrong, so we would probably not write this. But if you leave it like this, number 80, and then let anybody in your code, anybody, use it, like most people do this. Most people do this stuff. I'm sure you know what I'm talking about. Yeah, that's a very, very popular constant in the Java world. And you define it only once, you declare once, and then everybody can use it from different places. And then this data, this poor piece of data, who is staying here not knowing anything about who is using this data. So the data is naked, completely in front of everybody, and then other pieces of code from random places, from unknown places, use this data. So when I look at this line, I have no idea who uses it. I have no idea who depends on it. And I cannot do like this. I can't do it because I don't know who depends on it and how many trouble this may cause in the future. So my constant, this is the constant, gets turns into a hostage of the code around it. So the code around it now use it and don't want to relieve it, to release it, to let it go. And the more dependencies it has, the less meaning it has. It loses the semantic, it loses the meaning, it loses any context. Because in this case, it was okay when it was private. It was pretty contextual. So this port was related to only two methods, and we were able to understand what the port meant, especially with the Java block here, with the Java doc block here. It was properly explained, and we knew who is using the port because it was private and it was kind of a small piece of Java code. If you do it like this, and you let anybody use it, in a few 100,000 lines of code around, you will have no idea who uses this. This piece of data will become a terrible place that concentrates bad code around it. So this is not a solution. This is not how you solve the problem of magic numbers. Don't use these private static literals because they only harm you. It doesn't do better, it only does worse. So what's the solution? There are two actually solutions, two options. We are in the object-oriented programming world. So the first option, you may guess, is to use, guess what? A private method. If you want to get rid of this port, you don't declare it like this. You say return with port, and then you do it like this. I'm making this up, but you get the idea. So like this, and then well, of course, that's should be more complex, maybe like this. And then you introduce a private method. And you say private string with HTTP port, URL, and the path, which is for example, I don't know, nothing. And then you do return. This is not really Java. Yeah, so with the HTTP port, you do URL plus like this. So now you have this number 80 in one place. It has its perfect place. It's located where it should be, and it is used right there. It is located where it should be, and the user of the number, the user of the magic number is right here. Here it is. That's the user. So we do not disconnect the user of the magic number with the magic number. They always stay together. In this case, we know exactly what this number is for. If we want to document it, we put the Java doc here. And we say the number 80 is coming from the blah, 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 blah. So you want to document, you keep the code, you keep the executor, the user of the number together with the magic number. They must stay together. And the same for magic strings. And of course, in this case, this method will not be able to touch it. There's no possibility for a new method to use this magic number anywhere else. Nobody will have any ability to touch this number and to connect to this number from any other place. That's how it should be. That's the right approach. The approach number one. And of course, you understand that even a better solution, a perfect solution, you know that in a proper object-oriented programming world, we don't have private methods. I think private methods were invented by people who did not understand object-oriented programming. It's one of the mistakes they made in C++, in Java. So private methods, they have private and protected. Protected, it's a little bit different story, but private methods are just an indicator of bad code. If you have private methods, it means that your code is not object-oriented, that you're doing something quite procedural inside your object. So your object is too big, and then you don't know how to break it down into smaller parts, and then private methods are going to help you, are going to save you. So it's not a good design pattern, design method. So private methods are bad. So this is the really bad idea to use private method. It's okay. It's better than the magic now. It's better than than this one. It's much better than this garbage, but it's still not perfect. So the perfect approach is, you may guess, introduce an object, a new class. So the proper solution is this class with HTTP port. It'll look like this, and then you private final URL, private final pass, whatever. Then you make a constructor. Then you encapsulate. You know what I'm doing, right? And then you do something like, I don't know, to URL. It's not a real code, but you get the idea. And then here you do new with, there you go. That is a perfect object-oriented approach to solving the problem of magic numbers. You see a magic number, you see a magic string, you don't do stuff like this. You keep the magic. So you don't do these slashes. That's just silly. You keep them as magic. You keep them the way they are to make the code as readable as possible. Because that was like this with the slashes. This is unreadable code with the slashes. We don't want slashes. We want real code. We want to see what's happening. We want the column. We don't want to read this stuff. We want this. We want to have HTTPS host slash and then the number. This is the readable code. This code is readable. When you replace this stuff with some magic things with the constant names. You make your code less readable because I need to click here to understand what you meant there. For the slashes, I need to click and know, okay, slashes means what. You don't do that. You want me to read everything here in just exactly one line. And when you see that there is then there is not enough meaning of that this 443 needs some explanation, you either explain it here with the Java doc, or you create a new class which will encapsulate the number 443, which will know inside what this 443 means, and then it will process this number inside and do everything inside. So when you see something which is duplicated around the code, which you see something that the semantic is not in the meaning, the semantic is not rich enough, then you introduce a new class where you encapsulate everything that stays around this constant, this magic number, and do it everything there. That's all I wanted to say, actually. I will try to read your questions. Maybe you have some. Yeah, somebody's saying that I'm programming too much in Ruby, which is true. Yeah, I write Ruby quite frequently, and that's why there's stuff for the Java. Of course, in Java, you cannot do the default parameters, unfortunately or luckily. I don't know. So, yeah, there's a good comment that we need to reuse the logic. So that's a good definition of what's going on. We need to reuse the logic. That's right. In this case, we probably that's a perfect comment that we before here we reuse the data. Here we reuse the logic. So don't let people use your data. Don't let not only people but yourself. Don't let yourself reuse data. Reuse the logic. This is the logic which keeps the data inside. This is the logic, this is the object which encapsulates the data, and we don't care about the data. All we care is about, here's the object which does something for us, meaning concatenating the data or using the data, whatever. But we don't let anybody touching this number 80. Nobody would be able to do that. So every time you see private, static, literal, blah, 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 you have to understand this programmer is a bad programmer. It's a wrong design. Something is wrong, meaning that the code is falling apart. That you definitely are welcoming other programmers to reuse the data. You're saying, hey, I have some data for you. I have this column for you. How about you jump in and reuse it for whatever reason you want to use it, for anything. And then this column here means something. For example, this column here means I don't know. It's part of the URL. And then in some other place it may mean something completely different, like with this UTF, for example, 8. The UTF-8, for me, it's important to have it UTF-8. But for somebody else, it may be necessary like this or okay to use like this. But I'm not going to find them anyhow. I will just be afraid to change anything. So that, I think, was my main point. So private static literal is bad. Public static literal is horrible. It's like completely wrong because that makes your stuff available and visible by anyone, by any other code around you, anywhere. So if you have any questions, you can drop them in right now. We have about 10 minutes more. What are the tricks? Okay, the first question is, what are the tricks? What are the tricks to avoid private methods? Well, like I said, the private method, if you have a private method, it's bad. If your object needs a private method, then it means that the object is too large, too big, and you need to break down its methods into smaller elements because they're too big. So what else you would use private methods for? To split your large public methods into pieces. Don't split them into pieces, introduce new objects. Extract some functionality, extract the logic from your public methods, and make some smaller classes like this. Smaller objects, smaller classes. You can make them this embedded classes which stay inside your class. You can make them external classes which stay inside your package, whatever. But every time you see that your method is too long, too big, then and you need a private method, then introduce a new object. Private methods and private static methods, it's all wrong. It's just a workaround for a bad design. So your design is bad, it's growing big, your object is too big, and you don't know how to split it into pieces, you don't understand it, and then you say, okay, how about I make it a private method instead of having a large public method. It's a workaround, it's not good. There's another, would like to see a practical example. Well, a practical example of this I cannot provide within this webinar, but you can take a look at some of my recent repositories in Java on GitHub. I try not to use private methods at all. I just don't do it. Well, for the last few years for sure. Before I wasn't clear, I wasn't sure about that. I was using them quite frequently. Now I realize that that's definitely a mistake. Is it okay to call new outside the constructor? Yeah, that's a good comment. Of course, we understand that this new is kind of not a good practice in general, so it's better to have it as a constructor. But it's not the topic for this. It's not something we're going to discuss today. So it's for something for the next step of refactoring. Of course, this is kind of a hard wired dependency, so we depend on this class, and it's impossible to mock this dependency, it's impossible to break this dependency, but that's a separate story. You can also use parameter port and HTTP method. Yeah, that's right. Yeah, there are some other comments about the formatting of the names. I think that's enough for today. I think we don't want to waste any more minutes of your time. I think I said everything I wanted to say. Just stay away from private static literals, from public as well, and use objects, use classes. Keep your logic together with your data as close as possible, and never let them stay in different places. Keep them together. Inside a method, okay. Inside a class, even better. There is a comment that if you would use lots of classes, it's not good for memory uses. Static literal use much less memory than new class. That's a valid comment, but we don't care about this. I know that object-oriented programming is resource consuming, memory consuming, time consuming, but we don't care about that within the scope of this discussion. So we want the code to look great first and then work fast second. So design it the way I suggest, design it the way it looks like object-oriented code. And then if you have problems with performance, if you have difficulties on running this code on specific environment, on some computer, in some amount of data, then in this case you refactor it and introduce some static literals. But I guarantee you that it will happen only in a few really random, very rare cases. Not everywhere. Sometimes, yes, but in general, do it the right way. So, okay, thanks for listening. There's a question about elegant objects, volume 3. I'm working on this. Read my book, Elegant Objects, is the one which actually says something about the same things I'm saying on my webinars, and I see you next time. I'm trying to organize this webinar every first Wednesday of the month at 11 in the morning Pacific time. Thanks for being here. Thanks for listening. Stay tuned. Bye-bye.